Hello, everyone. So the name of this talk, as you can see, is From Pets to Cattle, the Way of Kubernetes. And we are going to explain actually, first things first, this analogy, and why is this analogy has some meaning about some pets and some cattle. And we are going to try to move, let's say, an old school application to the cloud with Kubernetes. My name is Álex. I am González, RO, on Twitter, GitHub, Gmail, and all the places. So if you want to ask me some question, just send me an email or some Twitter. I work at Java Talent engineering team in the core team, backend, not Android, sorry. And so this is a small agenda about what we are going to talk. As I said, I'm going to explain the title. We are going to make a small introduction to containers. I will explain some Kubernetes concept and architecture through an example, and we will have some time for questions later. So, this is a pet. How many of you have pets at home? Yeah, you love them, no? So if they become sick, you go to the doctor, you try to heal them, and you bring them back home. And this is a cattle. So sadly, a cattle is just a resource. Usually they don't have a name, perhaps they have a number, and if they become sick, you try to fix them for a little bit of time, and if it doesn't work, I'm sorry, you need to do whatever you need to do, and put another one in place. So it's more or less the same for the servers. Some time ago, if a server goes wrong, you try to SSH on the server or run some Ansible scripts and try to fix them. And nowadays, what we tend to do is we just kill that server and we create another one in the same place, because we will spend more time debugging the error. I mean, if the error is not repeatable, but we will spend more time debugging it and trying to fix it than just put another one in place. So containers. This is like the hipster war of the moment since 3 years ago. How many of you know about Docker and running it in production? Nice. So this is not something new. This is coming from the past. This is actually some pretty old technology as well. This is a small timeline about, I will need to read it because I don't remember the dates. I even don't remember my birthday. So actually on the 82, we have chroot, which was a way of inside a folder, let the user just log in inside a folder and don't let him see the rest of your system. Like, this was pretty useful for FTP, for example. You let the people FTP in your server and they just have this public HTML of their web page. Later on, we got jails from FreeBSD, which was a little bit more complex than that, but it was perhaps the first seed about the containers. And then we got some things in the middle, like Linux vServer, which was a private virtual server from Linux. But the important bit for us is C groups and namespaces. Basically, C groups allows you to group some processes together and give them some resources like CPU or memory or I/O. And namespaces lets you to do those processes. Basically, they can become root inside their context. So this is why we have later on rooting our containers in Docker. Another important bit before Docker is LXC, which is some tooling that Linux adds in top of C groups and namespaces. In the middle as well, I mean, Docker seems like it's in the day-to-day of everybody, but it's just from 2013, it's 3 years ago. And in 2014, we got Kubernetes, and we got Rocket as well, which is another container engine that runs in top of Kubernetes if you want. This is how the old school architecture works. Basically, we have some infrastructure, whatever, some infra. And in top of that infra, we have an operating system for that infra. And we have an hypervisor, which is the one that is going to control our virtual machines. Our virtual machines are completely machines, so they have a guest operating system, and in top of that, they have a user namespace tooling, like their bin, their libs. You can have one for CentOS, one for Ubuntu, and then in top of all that, you have your application. In Docker, it looks a little bit more like this. So the layer in the middle disappears, and we have the Docker engine. So we basically have a kernel that is compatible with the things that I said before, C groups and namespaces, and then we can run our applications and the user namespace applications of Ubuntu or CentOS or whatever in top of that. Another cool thing that Docker introduced, so a part of tooling, is this packaging. This is a MongoDB package for Docker. So the important bit here is that each of these steps that you see in that file is a different layer. So basically, when you build a Docker file, let's say that each of these steps is going to do a commit. And you can roll back those commits, and you can go back on those commits as well. And another important bit is that if you have two Docker files that are actually the same, but for example, let's say that the last line is the only one that changes, all of that is going to be cached. So it's going to be shared between your different Dockers, your different Docker images. So this is pretty good when you are doing deployments because you don't really need to download everything. You just download some bits of it. So for this Docker file, what we do, we base on Ubuntu, but you could base in some other thing like a Fedora machine or CentOS or whatever. We add some metadata to it, which is Docker in this case. Probably you would like to add your email there, but I just got this example from the Docker repo. And we install Mongo from apt, and we create some folders, and we say, okay, I want to expose this port, which is the port where you access to Docker. So far, so good. So this is a way to package your applications to run them in top of Docker. Let's go with the example in real life, like how we are going to move an old school app to this new paradigm. So I know that my design skills are not the best. Imagine that the yellow bit is your node, is where you are running the application. And inside your node, you are running three applications. You are running a MySQL server. You are running Ghost, which is WordPress for hipsters. And you have engines on top that is going to balance the request to Ghost. Ghost is a Node.js application. Probably if you need to do this today, you will just create some Ansible scripts or even SSH to the machine and install Ghost and install MySQL and install Nginx. Okay, but we can do it with the new concept that we learned, the containers. We could do it like this. We will create a Docker file for each of these applications that we need to run, and we are going to package them in a container. What do we do with this container when it's ready? So we need to build it, and if it's in your machine, you can just run it. But usually you don't build it. You don't build it for running it in your machine. You build it to run it in some server or something. So we have something called the registry. The registry is something like GitHub, but for Docker containers. So basically, you load your images to the registry. As well, the registry is going to have some cache. So if you just change some bits of the image, for example, Ubuntu is not going to download Ubuntu each time that you are uploading an image because it's already cached in the registry. The registry, it can be private because you don't want your application to be available to everybody, or it can be public. Docker have a hub, hub.docker.com, where you can find images for everything. Probably for these three, they are going to be already on the registry. You don't need to do them yourself. But here is when this becomes interesting. So instead of having one node, we are going to have 4 nodes in our servers. Because basically, we went to Hacker News, and we want our application to be high availability, and we always want our restaurant webpage to be there. So this is what we will do. This is the first step. We get one node, we get our containers, and we put those containers into the node. But this is, I mean, you have advantages of doing it like this with containers, but it's more or less the same that we had at the beginning on the first slide. This becomes bigger, and we want to do some horizontal scaling. And horizontal scaling, how do we do it? So we copy the node. But we cannot copy the node because we don't want two MySQLs. We just want two Go's and two engines on top. And if we had some Ansible scripts for running that, we are in a problem now because we need to check if it's the node 1, then you run MySQL. If it's not, then you don't run it. So far, we got something like this. All of us were here. I mean, first time that I deployed some applications in Docker, I was creating some Ansible scripts, and I was doing the orchestration by hand, like, OK, I'm not using that server that much. Let's put another container there and get some other container out. But now, we don't need to do it that way. We have orchestrators. We have Kubernetes, which is the one that we are going to talk about now. But we have as well some Docker Swarm, some Nomad. We have even Mesosphere. So this is not just Kubernetes. We have several to choose. It depends on your use case. Álex, I don't know if he's here, Álex González is going to talk about this on the track A at 6 p.m. This is some spam. But if you are interested about the difference, go there. So let me read this because I don't know it. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. This is coming from the Kubernetes documentation. But I prefer lists. So this is what Kubernetes is going to do for you. Kubernetes is going to schedule the containers. This means that instead you go into the container and say, I want to run this container on the node 1, and I want to run this MySQL just in the node 1, but I don't want it in the node 2, Kubernetes is going to do that for you. It is going as well to control the life cycle. So imagine that one of your nodes goes down, it's going to get those pods that were running on that container, and it's going to reschedule it in some other nodes. It has as well some private network. If you were dealing with Docker, you know that the network between containers is pretty difficult sometimes. It's going to fix that for you. And horizontal scaling just means that if you have more machines, you want more applications running in those machines. And vertical scaling, this one-on-one, is like you just make your machine bigger. But Kubernetes just does the horizontal scaling. It allows you to do rollouts and rollbacks with zero downtime. I mean, it depends on the strategy that you choose. But you can say, OK, I want to deploy this new version of the application, and it's going to be redirecting the request to the new application and not to the old. And when the old doesn't get any request, it's going to turn down those applications. And it has some extras that we are going to talk about, like service discovery built-in and some storage with plugins for volume storage and some secrets as well, which is if you need to store some password to use it in your node, you store it in a secret. Sorry. So remember what we had, and this is what we get now in Kubernetes. So in Kubernetes, the difference between Kubernetes and Docker, well, the difference. Like one of the most important bits is that the concept of container doesn't really exist on Docker. I mean, you can create containers, but the minimal amount, the minimal thing that you can create in Kubernetes is a pod. And a pod can be one container or can be several containers. So, for example, in the case of Ghost and Nginx, where was one then to be together? Because it doesn't make any sense to have an Nginx without the Ghost and the other way around. In the case of MySQL, it doesn't really mind where MySQL is. So for that, we create pods. These pods have some attributes, like they live together and they die together and they get rescheduled together. So you cannot, if you create a pod with these two containers inside, you're not going to have one container on one node and the other container in other. And as well have some cool stuff like readiness proof, which lets you know when your pod is ready to serve requests, for example. You can do that through an HTTP request, or you can use some script, some shell script, to check if your pod is ready. You cannot really do that in Docker. I mean, there are ways. But actually, now they introduced one, which is breaking the standard, but that's another story. But basically, what you will do on Docker is you run the Docker container, and then you do a curl and in a loop to see if it's working or not. Kubernetes is doing that for you. I mentioned before the secrets. So, for example, here you can see a use case for the secrets. we have MySQL, and we don't want to store that MySQL password anywhere in our GitHub or in the Docker file or anything like that. We will create the secret in the cluster itself, and we are going to use that secret inside our pod. How do we use that secret? We have several ways of using it. We can use it as an environment variable, or we can mount it as if it was like a normal volume, and just access to it like if it were a file, if it was a file, sorry. And there is more important bits here that I want to explain. We have volumes, which seems pretty stupid because you say, okay, I always have my hard disk on my nodes. But the difference here, when everything is in the cloud and you don't even know where the things are running, when, for example, in Docker, if your container dies and you create a new container, you're losing everything that you have in the container. With Kubernetes, you can create volumes which are persistent or not. If they are not persistent, it just means that it's going to live with your pod. So if your pod dies, you finally are going to lose that data. But if they are persistent, is some storage that you have in your cluster, and you claim it when you want to use. Like, I want to use 10 gigabytes of data from the cluster, and it's always going to be there. You have as well something which is called volume plugins that allows you to use some elastic block storage, or some Flocker, or GlusterFS, Cinder, whatever. There are a lot of them. And there is something called config maps. So you see that we have an Nginx, and these Nginx usually have some configuration on etc nginx.nginx.conf. We can create that file with a config map. So we just create a config map, we load it to our cluster, and then we say to the pod, okay, you mount this config map in this place, in this file. Or we can access as well to it like environment. This liveness and readiness proof is what I was talking before. Liveness proof is just some health check that you do on your pods. So imagine that, for example, you don't want the pod to be alive if it takes more than 200 milliseconds to reply. So you can just kill it if it doesn't pass this proof. So in this example, we just have 4 nodes, and we have a small application running on it. But usually, when you run Kubernetes, you want more nodes, and you want as well more applications, and it's pretty difficult to keep track of what you're running inside your cluster. So what the people from Google came with is how they run in Borg, which is everything is labeled. And then you can query those labels. For example, for our Ghost and Nginx application, we are saying that the layer is web. And we say the version 1, final, this works, final. If you were in the university before source control, you know what I'm talking about. But the idea is that you can say, okay, show me all the pods that are layered on the web and that they have this version. And then you can expose those to the world, for example. So far, so good. We have 4 nodes. And we have the application running on the nodes, but we are not using all the nodes. We are not using all the nodes because we just have one pod running there that actually, if it goes down, it's not going to restart. How do we do that pod to restart, and how we create more copies of that pod? With something called Replica Set. Replica Set basically is a way to define the difference between the desired state and the current state of your cluster. Let me explain that. So the current state now is that we have one version of that pod and one version of MySQL. But the desired state, see that I let a blank space there, is that we want 2 copies of that. So we say, okay, the desired state is 2, but the current state is 1. There's a mismatch there. Let's schedule another pod. And Kubernetes is going to do that. Kubernetes is going to create another replica, and now the current state and the desired state is actually the same. In the case of MySQL, we just have 1. And I mean, this can be huge. You can say, like, I want 1,000 replicas. But usually what you will use is autoscaling. So for me, the important bit of this autoscaling is that you know that you have 2 kind of autoscaling in your node. One autoscaling is for infrastructure, like the quantity of nodes that you are running in your cluster, and another one is for your applications, which is the quantity of pods that you are running in your cluster. So what Kubernetes takes care of is the quantity of nodes, sorry, the quantity of pods that you are running in your cluster. So for example, in the previous case, if we have autoscalable on and we are already filling all the requests that Nginx can manage via CPU or memory is the checks that it can allow. So it's based on hipster, so it's CPU, memory, and IO. It's going to create a new replica for you. Cool. On top of all this, we have an abstraction, which is called deployment, which is basically an easy way for you to define all these things that you are running on the server. So in this case, we are going to define our 2 replica sets and our pods inside this deployment, and we are going to say to Kubernetes, OK, this is my deployment, just deploy it. You don't want to define one pod, send the pod to the nodes, or define one replica set, send the replica to the nodes. This is so cool, but for now, we are just in our cluster. We are not in the real world yet. We didn't tell Kubernetes any way to. The white is going to kill me. Let's change it. So we didn't say Kubernetes a way to expose these pods to the world. This is done with a service. So basically on a service, if you remember the labels, you can say to the server, OK, I want these labels to be exposed. And there are different kinds of ways of expose your pods. One of the ways is node port to have access between nodes. But this one that I am showing on the example is a load balancer. A load balancer, for example, if you are running on AWS, what it's going to do is going to create a load balancer for you. And it's going to give you an IP, and you can just give CTL get services, and you can access to that IP. So we are already on the internet. But sometimes we need something like this. Why is ingress important? Because ingress is the controller that is going to allow you to add SSL, or as well is going to have some small logic that allows you to go to different services. Like, for example, imagine that you have 2 different APIs. You have api1.jobandtalent.com and api2.jobandtalent.com. So on ingress, you can say, OK, the ones that are coming to api1.jobandtalent.com are going to this service, and the ones that are going to the other one are going to the other server. So this is more or less how a server will look for you. We have the nodes in yellow, and inside those nodes we are running some deployments. Each deployment can have their own replica sets, and the red bit is the pod. So imagine doing all this with SSH scripts or with Ansible scripts or with whatever you want. It's doable, but it's a little bit more difficult than doing it like this, because this is just a file that you are defining, deployment.yaml, and that you are going to send to the cluster. And we have another important concept in Kubernetes. I promise that this is almost the last concept. The namespaces. So namespaces is basically a way to create a virtual cluster for your teams. Like imagine that you have a team of backend and you have a team of QA, and you don't want the people from QA to be testing the things through live. It's going to test in a copy of what you have on live, but in a different namespace. So it looks like this. So we wrote it, we split it, and we give a bit of controlled via resources of your nodes to some other team. Okay. So we have some special cases on Kubernetes, because the example that I was talking before is cloud native. Let's say that there are cloud native applications that you can scale them horizontally and nothing is going to happen. But this is not always like that. We have some applications that they require, for example, some index on the host name, or they require to do a resharding when you recreate a pod. And for this, they create pet sets. So imagine that, for example, you want to deploy a Cassandra cluster, and this Cassandra cluster will have some hosts that are going to be Cassandra 1, Cassandra 2, Cassandra 3. But if you get Cassandra 3 down, then probably the server will need to do some resharding, so you need to let them know that this is going to happen. And this is the pet set. And the daemon set is basically a way to run one and just one pod on each of your nodes. So imagine, for example, that you have a data.agent or something, and you want to run it in all your nodes of your cluster. You are going to run this. And this is a little bit how the architecture really simplifies of Kubernetes is. We have in the top the users, and the users are going to access to your cluster through kubeproxy. And we have in the bottom Look, which is your admin, and is going to access to the Kubernetes master to manage your cluster. So you don't really go to your nodes and you say like, okay, I want to do this in your nodes. You go to a layer that they have on top, which is Kubernetes master, which is as well something that needs to be highly available, because if not, you are going to lose control of your cluster. And it stores the state. If you remember the current state and the desired state, this is how everything is stored in etcd, in Kubernetes master. They don't need to be all on the same machine. They can be distributed, but the idea is that try to don't lose etcd. If not, you are going to lose the current state of the cluster. What they recommend actually is doing some backups about etcd in case that you lose it. And this is the same, but without the nice draws that they add. I'm going to expose this later on internet, so you can access to it. If you are more interested about the architecture, is how it looks like, more or less. We have the nodes and the pods running on the right side, and the left side is how the Kubernetes master is looking. Kubernetes master is as well the one that is taking control of the replica sets and checking these states. Cool. I was talking about the YAML files before and how do you define the things that you're running in your cluster. And this is a small example. This is not a full example, it's just a bit. Actually, it's on internet. If you check Ghost Nginx Kubernetes, it's going to appear this. Basically, you say that you want to create a deployment. You add some metadata to your file. This metadata is going to be usable later if you want to query for it. And you specify a template of what you are going to run. In this case, I am just showing that we are running a container named Nginx, but if you keep reading, it's going to say, okay, I am running this container, and I am running as well a container for Ghost, and then in another template, you are going to run your MySQL. And I didn't want to finish without saying, without talking about jobs and scheduled jobs. So basically, if you want to run, for example, a migration, this is going to be a job. You launch the job, it's going to be run once in your cluster, and when it's finished, that's it. And then you have something called scheduled jobs, which it was going to be introduced in 1.2, and it was introduced in 1.4, I think. And basically, it's a distributed cron. So you can create a task for doing a backup every night at 2 a.m., like a proper cron, but it's going to run in your cluster. And that's it. I promised that it was going to be longer, but I speak really quick when I am on the stage. So sorry about that.